Hey everyone. So today we are diving into one of the most important risk management tools used by traders, portfolio managers, and banks. That is value at risk. But instead of just talking theory, we are going to calculate it hands-on using real data from foreign exchange portfolio which I handle, and the exposure consists of two currencies: Indian rupees and Japanese yen. Okay. So by the end of this video, you will understand exactly how the historical simulation method works and how to calculate it step by step in Excel. Okay. So what exactly is VAR? So VAR is simply a maximum loss that I can expect with a certain level of confidence over a given period of time. So there are two things required for VAR: the time period and the confidence interval. For example, a 95% VAR of $5,000 will mean that I have 5% chance to exceed $5,000 in one given day. So it's a basically a statistical measure of downside risk. There are three major common ways to calculate it: historical simulation, parametric or delta normal, and Monte Carlo simulation. In this uh, session, we are going to focus on historical simulation because it's very intuitive and very simple, and also it does not assume that returns are normally distributed. So let's start with our portfolio. So in this portfolio we have a portfolio value of US dollar 1 million. It consists of two currencies: USD INR and USD JPY. INR consists of 60% of this portfolio, and JPY consists of 40% of this portfolio. And we are going to calculate three uh, VARs: 90, 95%, and 99% VARs. And we also have the data. We have a data of 1 year closing rates from 23rd October 2024 to 23rd October 2025. Both it is for both the currencies. So what we are going to do is we are going to first find out the per day percentage change. So we are going to calculate daily returns. Okay. So let's start with the daily returns. So it will be for this minus this divided by previous value. It will be 0.0071%, and we can just calculate for all those values. Similarly, we can apply similar formula over for dollar JPY, and we can calculate the returns, daily returns for dollar JPY as well. Now, so first, what we did, we just put on the data. Then on second step, we calculated the daily returns. Now in third step, we are going to calculate the portfolio value. Okay. So how will we get the portfolio value? So we are going to get MTM from this portfolio return, that by how much it is jumping this portfolio value. So it is very similar. What we are going to do is, first we are going to take percentage change in dollar INR and multiply it with the weightage of dollar INR. Second, we are going to add percentage change in dollar JPY and multiply it with the dollar JPY weightage. And then we are going to multiply this whole thing in with the portfolio value. That's how we will get the portfolio change for from 23rd October 2024 to 24th October 2024. And now, since we want to drag this to all the values up to next year, so let's freeze some of the values which are not going to change. Okay, so we just try and freeze the values. and that's how we are going to get the returns here. Okay, so since we want to find out 90% confidence interval in this array, so we can have two option, either by just short it down from lowest to highest and then calculate 90th percentile in this range, or we can just directly use access formula percentile dot inc. Okay, we are going to just take this array, comma, 1 minus this value here, right here. So we find out that we are for 90% confidence interval is uh, 3600. So let's freeze again these F columns because we want to drag it for other VARs. So just when we drag it out here, so for 95% it is $5,068, and for 99% it is $9,707. We can also make these in okay. So these are the VAR values. So now, so how do we interpret? So let's find out that what it means. So now you know the how to compute VAR using historical simulation. But let's be real, it's not perfect. It assumes that past is a good indicator of the future, which is not always true. It does not tell you how bad losses could be beyond that particular threshold from above 90%. That's why institutions often calculate expected shortfall or CVAR. We're going to calculate that in next video. Okay. So so now you know how to calculate historical simulation approach step by step from real data to real numbers. If you find helpful, we are going to do. You can check out other videos. We are going to calculate same VAR using parametric approach and then Monte Carlo approach. Okay, you can find out these videos in next section. And we are going to also calculate this historical VAR using the Python programming language. So you can check out that as well. Thank you.